In this example, we are going to do two different kinds of things. They feel like they're asking the same question where we're looking to find the net area and the total area or area, but they definitely are different. So a net area is going to have, if you have positive areas that count as positive areas and negative areas count as negative areas. And so they kind of may counter each other. Versus total area, you have to do a little bit more work. You have to find out what the total area is. And so actually a negative area is actually going to count as a positive area because it's area. And so you can't just do what you normally do on a net area type of a question. And so we have to figure out where the positive areas are, where the negative areas are, and then basically do the absolute value of the negative areas and treat them as just area and then add it all together. So a little more work on area or total area versus finding the net area. So for net area, we're going to be, here's our equation, and we're bounded from -1 to 2. And so that would be us just doing, finding the area under the curve, which is us doing the antiderivative or the integral from -1 to 2 of this equation. All right, so for us to do this antiderivative, we're going to add our power divide. And so we're going to have 6x to the 4th divided by 4 minus 6x cubed divided by 3 minus, I lost the x on that, minus a 12x squared divided by 2. And we're going to go from -1 to 2. So let's clean this up. Then we can plug in -1 and figure out what our areas are. So here we are going to get a 3/2 x to the 4th minus a 2x cubed minus a 6x squared, -1 to 2. All right, so the math is we are going to plug in 2 into this. So we have a 3/2 times 2 to the 4th minus a 2 times 2 cubed minus a 6 times 2 squared, and then minus, so that the area of this one minus the -1 plugged in, right? So that's going to get us a 3/2 times a -1 to the 4th minus a 2 times -1 cubed minus a 6 times -1 squared. All right, so we're going to figure out the area of that, subtract the area of that, and see what we get. So we do this, we're looking at 2 to the 4th, 2, 4, 8, 16. 3/2 of 16 would be 16 divided by 2 is 8 times 3 is 24. And then this is going to be 8 times 2, so minus 16. And that is 4 times 6 is 12, so minus, that's 4 times 6 is 24. All right, so there's the area of that chunk minus, this is going to be a positive 1, so 3/2. And then this is going to be a -1 times the -2, so we're going to be adding 2. And then minus 6. All right, so we're looking at 24, but minus a 24, so a -16 on that piece. And then over here we have, let's see, we have a 2 minus 6 is a -4, so we have a 3/2 minus 4. So that would be a 3/2 minus 8/2, so -5/2. So minus a -5/2. And then we'll change our sign. So this turns into addition, and we need to put that over 1. So we're looking at a -32 over 2. 32 over 2 plus a 5 over 2 gets us a -27 over 2. Or you can look at it as 2 goes into that 13, so -13 times with 1 left over. So that would represent the area under the curve. So there's more negative area than there is positive area. Maybe it's all negative area. I don't really know. But we're going to need to know that when we do our total area. So for our total area, let's cut this in half here a little bit. And for total area, we actually need to know where the positive areas are and the negative areas and kind of do that math independently. So if I go up here, I'm going to take this space to try to actually, let's create a visual of whatever this graph looks like. So I'm going to set this equal to 0 and try to factor it and find where the x-intercepts are and get a rough idea of the graph. So if I take this equation, first off, I can take a 6x out of it. And so that would leave me with x squared minus x plus 2. No, minus 2, not taking negative with it. So minus 2. And then if I factor it further, I'm looking at an x minus 2 and an x plus 1. So solution-wise, we're getting a 0, a 2, and a negative 1. So graph-wise, we have a negative 1 and a 2. So negative 1, 0, and 2 are our x-intercepts. And because it's an x to the third with a positive, I know my end behavior is it's going to be going up to the right and down to the left. So this graph might look something like this. All right. And so based on this, my original answer when I found the area from -1 to 2, so -1 to 2, I did have more negative area than I do positive area. And so that actually makes sense that I ended up getting a negative area out of it because some of this positive chipped away at some of this negative. But when we do total area, we're going to treat everything as a positive. So what I'm going to need to do is break it up and find the area of this and add the area of this. All right, now when I do the math, it's going to be a negative area, but I'll do the absolute value of it and make it into a positive. So we're going to do the area from -1 to 0. All right, and then our equation, here it is 6x to the third minus 6x squared minus 12x. But we've already done that antiderivative. And so that turns into this one cleaned up. So 3/2 x to the fourth minus 2x to the third minus 6x squared. And we're going to go from -1 to 0. Right? So if I find that area, that should be my positive area. So when I do the math here, it should be a positive. I'm going to be plugging in the 0. So that whole thing is just going to be 0. And then when I plug in the -1, we've already plugged in the -1. That gets us a negative, right here, a -5/2. All right. So it was a -5/2, and then we ended up subtracting. So that area of when we plug in the -1 is a -5/2. And so change our signs again. That area is 5/2. Circle that, yeah. All right, so that's part of it. And then I'm going to do the other side of this. That the other side of this is going from 0 to 2, and that should be a negative area. So same thing, we're going to go from 0 to 2, same equation, 6x cubed minus 6x squared minus 12x dx. And we know the antiderivative of it is this. And so we have a 3/2 x to the fourth minus 2x to the third minus 6x squared, that we're going from a 0 to the 2. So if I plug in 2 first, I did that over here. So I plugged that in and we got a -16. So I'll plug in that again, get a -16. So there's our first one, and we are subtracting the 0 plugged in, which is just 0. So that ends up being -16. So they line up how they should. I should have a smaller positive area and a larger negative area, but they kind of negate each other, right? Or sorry, they don't negate each other. We're finding the total area, so I actually want to take this area. So total area is going to be us doing the positive as a positive, and we're going to be adding the absolute value of any negatives. All right, so I need to make that a 16. I need to make this a, well, I can do it this way. This is a 2.5. And I'm adding a 16, giving us a total area of 18. All right, so same feel to the question, finding the net area versus total area, though, that is a different method or a different process. So we have to break things up a little bit different. Net area is very straightforward. Put your endpoints in here, what you're bounded by, and just do the math and let the math take care of itself. Versus when you're doing this one, you need to separate it out, find your positive areas, find your negative areas, and then add all your stuff together.